All right, hello everyone. Happy Thanksgiving, firstly. So hopefully you're spending some good time with your family. But let's get into the video. We're solving LeetCode 841 rooms and keys. There are n rooms labeled from 0 to n-1, and all the rooms are unlocked except for room 0. Your goal is to visit all rooms. However, you cannot enter a locked room without having its key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks. And you can take all the keys with you and unlock other rooms. Given an array of rooms where rooms I is a set of keys that you obtain from visiting room I, return true if you can visit all rooms or false otherwise. So let's quickly look at the first example. The way I like to think about problems like these is getting hints from the problem statement. It says that there's a number of rooms and there's keys that unlock other rooms. So that means we're going from room to room, right? So we can think about each one of these rooms as a node, and the keys are a directed edge to the next room. And I'm gonna quickly show you and illustrate this. So let's say this is room 0, room 1, room 2, and lastly room 3. If we start off at room 0, that means that there is a node 0. Next, it says that 0 has a key to room 1. So that means there's a directed edge to room 1. So this connects this node. Now we would traverse to room 1 and we'd say, hey, what's in room 1? Room 1 has a directed edge to room 2 because it has the key to room 2. So we can quickly go there. And we go to room 2 and we say, hey, this has a key to room 3. So we can travel to room 3. And we go to room 3 and it's empty. So we actually don't do anything. And as you can see here, like with this beautiful illustration, we can go from node or room 0 all the way to room 3 sequentially without any hiccups. So that means that we should return true because there's a total number of 4 rooms and we've traveled to a total number of 4 rooms or 4 nodes. And you might say, all right, I understand that, but how do we actually solve a problem like this? What we do is we use a scene set and we're going to add that node or room to the set every time we traverse to it. And once we're done, all we have to do is compare our scene set, which will have all of the nodes that we can travel to from node 0, and compare it to the total number of rooms. So in this example here, we'd have a scene set here. And of course, we start at room 0, so that's added. We go to room 1, then we go to room 2, and lastly room 3. And we say, hey, what's the length of the scene set? There's 4 values in it, so it has a 4. And we say, hey, is 4 equal to the total number of rooms? We check our rooms array and we say, hey, well, there's 1, 2, 3, 4. So there's 4 total rooms and we've traveled to 4 rooms. So that means we can travel to all of the rooms. Therefore, we return true. All right, and let's look at a slightly more complicated example, but nothing too bad. And it should help understand why we're using the scene set because it serves another purpose than knowing all the nodes we've been to. It helps us detect cycles. All right, so the same thing applies here. Let's have our scene set. Scene. And we start off at node 0 always because it's unlocked. So that's going to be default added into our set. And we start off we're going to have room 0. Let me quickly label them, 2 and 3. So node 0, which we can, let's just put this here, has a key. Let's look at the first key. It goes, hey, we have a key to node 1. So that means there's a directed edge from 0 to 1. So we travel there, and now we're at room 1. And we say, hey, what's the first key in here? We have a key to room 3. So you can go from 0 to 1 to 3. Now we travel to 3. So we've essentially went 0, 1, and then 3. Now we're at 3 and we say, hey, there's a directed edge to room 0. And if we go to 0 and we check 1, we would essentially enter an infinite loop because we go 0, 1, 3, 0, 1, 3. And it's a very, very quick fix. Since we're accounting for all the nodes in our scene set, like I forgot to add them here, but we have 0, 1, and 3. What we do is we'd say, hey, if we've been to the node already, we won't go there again. So when we get to node 3 and it brings us back to node 1 or node 0, we check the first room and say, hey, there's a key to room 1. Do you want to go there? We check our scene set and it's already been there. We've traveled there, so we don't need to do that. We check the next key, room 3. We've already been there as well. So that means that there's no more available rooms to check. So we'd end this depth first search function and we'd check the length of scene. So you see there's 3 nodes or rooms. So we've traveled to a total of 3 rooms. And the total number of rooms that we can travel to is 4. Is 3 equal to 4? It is not, so we'd return false. All right. So hopefully that makes sense. And let's go into how to code up a solution like this. So first I like to start off with my scene set. Just call it scene, create a new set. Next, we're going to create a depth first search function. So we want to define your function and call it DFS. And we're going to start off with a node. And now what we want to do is iterate through or check all of the keys that are available within this node or in this room. So we say for key in rooms at node. Just like in the first example here, we started at node 0. We go to rooms at index 0 and we say, hey, there's 2 keys. So we're just iterating over this list here. So let's just make sure we're all on the same page here. Next, what we want to make sure is we haven't been there before. So if key not in scene, so if it's not in scene, what we want to do is add it to scene. So seen.add key. And we want to actually travel to that room. So we're going to call the same function recursively. So DFS add key. Nice. And once this function finishes, we should have a scene set with every possible node that we can travel to from the origin point 0. All right, so what do we have to do now? Well, we have to add 0 to our scene because we always start at room 0 because it's unlocked. So we say scene.add 0. And next, we have to call the DFS function for the first time. So we're going to say DFS, and we're going to call it with room 0, because that's where we always start. And lastly, we just have to check if the scene set is equal to the length of rooms. So if return, if the length of scene, oh, a bit of a typos here, is equal to the length of rooms. And if they're equal, then that means that we can travel to all the rooms. And if they're not, we return false. Let's quickly try this out. There's always one small typo. I said for key and room, but it's called rooms. Let's put rooms there, quickly fix that. And there we go. We passed the question. Except for that little hiccup, make sure you always look at the correct variable names. But besides that, we've solved it and it's actually pretty efficient. So I hope you learned something new. Peace and have a happy Thanksgiving.